In this demonstration, we will show how Avidian SafeKit implements a Hyper-V cluster with real-time replication of entire virtual machines and automatic failover. Let's consider two physical Hyper-V nodes. On node 1, two virtual machines have been created. When we open the folder containing these virtual machines, we can see their names, VM1 and VM2. Each of these folders contains a virtual hard disk, which includes an operating system and a critical application. The goal is to configure the replication and failover of VM1 and VM2. On node 2, no virtual machines have been created. When we open the virtual machines folder on node 2, we notice that the VM1 and VM2 folders are empty. Let's start the SafeKit console to configure the cluster, beginning with entering the IP addresses of the two nodes. In the GUI, you have an option to create a new LAN and nodes. This can be useful if you want to define a dedicated replication network. Now that the cluster is configured, let's proceed with setting up the Hyper-V.Safe module for the VM1 virtual machine. Let's start by configuring the automatic startup of the module when the nodes boot. Now, let's configure the root path of the folder and the virtual machine name, which will determine the real-time replication to be performed and the virtual machine to restart in case of a failure. Finally, let's set up the custom checker to ensure the virtual machine isn't locked up, crashed, or non-functional. If any of these issues are detected, the custom checker will attempt to restart VM1 locally or remotely if the local restarts fail. The configuration of the Hyper-V module for VM1 is complete. Now, let's proceed with configuring the Hyper-V module for VM2. We'll follow the same steps as we did for VM1, but this time, we'll replace VM1 with VM2 in the parameters. As you can see, VM level high availability doesn't require defining which services to restart, which application folders to replicate, or which virtual IP address to fail over. It's the easiest solution to implement when you don't know how the application works. The problem is that this solution is limited to Hyper-V or KVM. For a solution that works in any infrastructure, you need to implement high availability at the application level. The configuration of the Hyper-V module for VM2 is complete. Now, we can proceed to monitor the two Hyper-V modules for VM1 and VM2. The first time, SafeKit doesn't know that Node 1 has the most up-to-date virtual machine directories. Therefore, it's necessary to force the start as primary of the VM1 and VM2 modules on Node 1. Once a module is started on Node 1 and the associated virtual machine is automatically started, we can then start the module on Node 2. The module on Node 2 will resynchronize the directory associated with the virtual machine before becoming secondary, ready to restart the virtual machine in case of a failure or a stop of Node 1. Each folder in each module containing a virtual machine is replicated in real time between the prim node and the second node. We can verify this on Node 2 by opening the folder containing the virtual machines. VM1 and VM2 are running on Node 1, while Node 2 is idle. SafeKit allows easy migration of a virtual machine from one node to another by stopping the module on the prim node. The second node then becomes primary and restarts the virtual machine. After the migration, we have an active cluster with VM1 running on Node 1 and VM2 running on Node 2. Now, let's simulate a crash of Node 1 by forcing its reboot. VM1, which was running on Node 1, is automatically restarted on Node 2. VM2 is not affected by the crash of Node 1 since it was already running on Node 2. Only the real-time replication to Node 1 is lost. Node 1 is now booting, and both modules start as they have been configured to start automatically at boot. Each module will first resynchronize its virtual machine folder before becoming second. This concludes this demonstration. On the website, you will find a free trial and the Hyper-V.Safe module with a quick installation guide to reproduce this demonstration on your own virtual machines.